My name is Derrick, Analyst on the Data Science and Analytics team at JetBlue. Excited to co-present today with Josh.
And I lead up our data and analytics practice at OnPrem Solution Partners. And we've been doing a significant DBT Snowflake project with JetBlue for the last 6 months or so. So very excited to speak with you all today.
Yeah, excited to share what we've been working on. I think that the DBT community is really special. I think it's part of my morning ritual is opening DBT Slack and looking at the questions people are asking and just the advice that's being shared. So I think it's a really supportive, smart, and fun community. And actually was going through a thread on someone who's just starting working with web analytics data sets. And they're asking, is it just really working with hundreds of columns? Is there a better way? And there's some suggestions in the thread, but ultimately there's like this question of, do you dislike working with wide tables? And I think that's a fair question, because I remember working with Adobe Analytics. It was actually one of the first data sets that I modeled coming out of DBT Learn. So I was looking at this web analytics data dictionary going like through hundreds of columns and just being a little overwhelmed and thinking like, I'm not in the Jaffle shop anymore. This is much more complicated. How am I going to manage just all of the model code? How am I going to build all the associated metadata in our markdown and YAML configuration? I think through that journey of working with this, I actually learned that there's some great tools with DBT that can help make this a painless experience and fun. So that way we can all channel our inner Diana Ross and say it with me. There just ain't no table wide enough that we can't model with DBT.
All right.
There we go. I'm going to talk to you today a little bit about some of the tips that we learned building out some of the initial staging models. So cleaning out this data for downstream consumers and some of the DBT features that make that easy and some of the tools that we've used. And then I'll hand it over to Josh.
Then we want to talk a little bit about the great work that Derrick did to transform and clean up some of these somewhat unwieldy, very large tables. The goal of that was ultimately to be able to take that data downstream and help JetBlue do more informative and useful analytics. So we want to start talking a little bit, and some of you may be familiar with these things, but sessions, I think most folks are probably familiar with, but also talk a little bit more about some things like flight searches and what that means to JetBlue and how we slice and dice it. Then we'll share a little bit of our dags, specifically the particular entities and how we had to do them in a step-by-step process to get the appropriate results. And then just a few other coding thoughts about dealing with large and complex DBT projects, so variable management, splitting up cyclical dags, and some general SQL gotchas.
So ultimately had two goals. You all can walk away with some tips on working with these large data sets and also learn a little bit of our experience modeling web analytics data. So just a little background on JetBlue's DBT project. We're working with 2,500 plus models on 40 different sources. You can imagine as an airline, we've got an amazing treasure trove of data, everything from flights and bags and customers. So we actually were initially challenged to replace our existing on-prem data warehouse with data warehouse in Snowflake modeled with DBT. And we did this initially in 6 months. There's a great talk by our analytics engineering manager, Ashley Van Name, and I'll share the link. So I encourage you to check out her talk, Taking Off with DBT, that really goes through how we built everything out. But it was a mad dash to get everything stood up. And now we're really going back and thinking about some of the decisions we made and maintaining our code and how we could do that better. So just a little refresher for Adobe Analytics data for any of you who might not be familiar. This is an analytics tool to collect data on different digital experiences. You think of a digital experience like a mobile app or website. So at JetBlue, we've got iOS app, Android app, mobile web, desktop web. Data is being collected as users interact with these pages and being stored in our Adobe Analytics data. So you can think about users searching for flights or hotels to book, checking their flight status, making a transaction. So if we look at just a small slice of what that looks like, you can see here that each record is a page view or an event that's been triggered on the page. We've got a table for each of our reporting suites. So this sort of maps to device types. It's highly configurable. So there's a lot of shared columns across different devices, but also some unique columns. And this works out to be about 500 columns for each reporting suite, with about 4 reporting suites, so 2,000 plus columns. So I'd be curious others' reactions on that, if you think that's like wide or not very wide. We're coming from, this is like one of the largest data sets that we're working with currently. Pre-DBT and Snowflake, we had chopped up these tables. There were like 100 column tables for each reporting suite. So end up with like about 20 tables instead of 5. And it's just unwieldy. You have a lot of these customizable column names that are being renamed in different queries. So just a big mess. We wanted to centralize all that with DBT. So one of the first steps that we did is build out some macros to load this data from a staging environment into Snowflake. So I think this is like the first example of just sort of me going from analyst brain building out queries to analytics engineer building out models. So here, when we're doing this copy into command, analyst brain says, okay, we can't select star, so we need to hard code each of the columns that we're selecting here and indexing. Silly, this is 500 lines of code. And the challenge here when working with these number of columns is think Jinja. You've got this great tool you can take for any of these repeating patterns. We can take this nice 3 lines of Jinja with this for loop to replace hundreds of lines of code. So that's going to make maintaining your code much easier. Another example here, so we have a lot of shared columns. Instead of repeating those columns in our select statement, we can have a shared column variable that we define in our model, and then we can reference that in our select statements. Again, you'd be saving yourself hundreds of lines of code here with much more readable model code. Another example that's been very helpful is the star macro. So in this first example here, you can think of this like select star, and then we can also pass in a list of fields to exclude. So you can think about if you want to select 498 of the columns of your 500 column table, you can do that here with just three lines of code, which keeps things nice. So just a few tips to keep the code base small when you're working with these large data sets. Going back to the workflow after we've loaded in this data into our raw database, then we want to clean it up. So we've got some challenges here with these ambiguous column names. We've got some flight search data here where we've got some airports, some search flight dates, some sort of cryptic values here. So we want to take and rename all these columns. We want to recast our types and add some description. So we want to do that on, like we said here, hundreds of columns. So this doesn't have to be too daunting. We actually have a few tips that can help to make this painless, including using CodeGen. So this is a nice package that was built out to build scaffolding for models. So here we can just run this on the command line or as a macro. We're passing in a source and table, and then we'll get that scaffolding to work with. Of course, in practice, usually we're going to do a lot more than just rename right here. So we want to also take our evar3, rename it as a booked flag along with some other columns, and then we want to recast that maybe as a Boolean, and then ultimately add some descriptions. So then we'll select booked, but wait, there's this challenge of managing multiple CTEs where we have these values that are passing to downstream CTEs. So it's just a little bit of introducing a lot of opportunities for different bugs. And I think that there's some strategies here. I think commonly there's this concept of final. You build each CTE, and then once that's complete, you rename it from final to the operation and work down the list. So I think that working sequentially for us, we just had so many changes going on. We also had several contributors. So sometimes you just have to manage what are all these rename values or what are all these type values. So we actually ended up using a separate document just to keep track of what we're renaming everything to, what we're typing it to. And that also was helpful with stakeholders to be able to share with them and get their feedback. But ultimately ended up building an internal tool that just took those raw column values, rename values, along with associated comments, and then just built that scaffolding out for us. I found that was much easier just to start from scratch instead of try to continually debug, and then at least work from there as the base model. Of course, we want to keep our commit histories and be able to track those changes, but at least from building that initial model was a helpful strategy for us. So along with building out the models, we also have all of that associated YAML. Okay, so again, not to despair, it's a lot, but again, CodeGen comes in handy here. There's a generate base YAML that we can use. We simply can pass in a model name, and it's going to helpfully generate some YAML scaffolding for us. So here, I've just run this here on one of our analytics tables, one of our stage tables. So here we can pull so many columns, right? Oh, there we go. Okay. So then it's just a matter of, we can now drop that into a code editor to work with. Beautiful. Now, this is something that I'm just super fond of. So most code editors are going to have this concept of multi-cursor or multi-select. So we can select some pattern here and then select all of it. And so that's pretty exciting. Now we have thousands of cursors at our control. Very neat. Also, what's very handy is we can do multi-copy and paste. So that's a lot of fun. And then it pretty much enables us to now build out our YAML file very easily. Done. Beautiful. So we just did that for hundreds of columns in 3 seconds. So the other helpful way to use this then is to build the associated markdown file with all of our column descriptions as well. So just a nice helpful tool. I could go on and on with this one, but I'll stop there in the name of love for multi-cursor and multi-select. So you saw we're using doc strings, doc blocks. One other tip here that we've used is dry docs. I'm a new father, so you have to forgive the dad jokes. I'm still working on them. But ultimately, we don't repeat ourselves with our documentation. We've got columns like metadata insert timestamp that's going to be available across all of our sources. So we build this common terms markdown file that we're going to put in our models and stage path. And then we've got a visitor ID that might be unique to a source. So then we'll put that in the source path, and then we'll have a column unique to a specific table. So we'll include that unique value in that table there. So that way, if we're making any changes to the column descriptions, it makes it very easy. And lastly, working with web analytics data, you're going to have a lot of these sort of ambiguous ID values because, of course, you've got incredible volumes of data. Of course, you want to normalize your data. It's a new paradigm. We want to add in that description, and we want to trust Snowflake to handle the compression on that. What we can do is add in these description columns. So now we know, okay, the referral type ID of 3 is actually a user coming from a search engine. So we do this in a number of different ways. So you can add in descriptions with a case statement. Okay, but now we're adding in extra lines of code, making our code a little difficult to read. So what we can do is join in the description on either a lookup table. So that lookup table can be a seed. So this is the helpful built-in feature of DBT. So we've got seeds. So we put these lookup tables in our data path here in our project for each of the sources. This is then where we can maintain those lookup tables. So a lot of the web analytics lookup tables might be pretty static or change infrequently. So this is a nice use case for seeds, but you'll also come into IDs for browsers where you've got continual browser versions incrementing. So those we actually have as separate models with the associated lookup tables that come in the export data, and then we'll join on those stage tables. Cool, so we've taken that raw data, transformed, cleaned it up using some Ninja, and some macros. And now we're ready to pass that on for some downstream transformations. So we have all of our different stakeholders, our web team, our revenue teams, our data science teams to be able to use this data to answer different questions.
Thank you, Derrick. So I think all of the work that Derrick did in order to give us nice data types, nice meaningful column names, a lot of these other things was key, because as anybody who has worked with web analytics data knows, there's a lot of complexity in there. So when we wanted to take this data and then be able to start building some useful models that corresponded to JetBlue's idea of certain business entities, it was key to have this somewhat cleaned up. I keep wanting to say Omniture because that's what it used to be, but now it's Adobe Analytics data present for us. It significantly reduced the workload that we otherwise would have had to take on. Some important web analytics terms that we should explain as we get started here. So a session or a visit, they're interchangeable terms for a customer's web or app journey, because JetBlue has obviously a desktop website, but mobile apps for iOS, Android, tablets, all of that. One or more page views. A visit expires after 30 minutes of inactivity or 12 hours of activity, even if you're pinging it more often than every 30 minutes. A flight search is essentially each unique origin and destination and date combination searched for on the select flights page. Now, one thing that turned out to be important is we were originally thinking about this is every time you click on the JetBlue website and do a search, it ends up being one row in this table for someone to analyze. As we dug into the way that business users make decisions at JetBlue, some of the various internal teams, it turns out that folks don't tend to care that much about how many times did someone click on the website. What they want to know is how many times did a search look at a particular connection between two locations. So if you were to do a round trip search, so one search on the JetBlue website, say from LAX to LaGuardia and back, that's one search, but that's two flight segments. So the table we ended up building out of this wasn't really just flight searches, it was flight search segments. Then looks and books, both, it turns out that many of the analytics that we want to do at JetBlue aren't just about how many total searches were done or how many total bookings were done, even if someone did more than one of those in a session. It really tends to be more how many sessions had a flight search as part of the session, or regardless of how many searches were done under the session, it's just yes or no, how many sessions, and then the same thing for bookings. So that's what a look and a book is. Next slide, please, Derrick. So here's a simplified DAG of what we did. Turns out that we first, and I'll talk a little bit more about how to break apart cyclical DAGs, but we first needed to get a unified notion of the session. We needed a table that had one row per session and a couple of basic metrics in there, because what we needed is we needed then the session key, which we built an artificial hash key off of certain columns in the session staging table, to then build a couple of subsequent tables. So one for flight searches, like I talked about, which is actually flight search segments in the end, if you look at the data in the table, and flight booked PNRs. A PNR is a passenger name record. It's that 6-digit alphanumeric code that you get whenever you buy a plane ticket. So flight booked PNRs could have multiple rows, even if you made multiple bookings in one session, but both flight searches and flight booked PNRs end up aggregating up to our books and looks tables, where there is a maximum of one corresponding row per session. Session staging, flight booked PNRs, and flight searches also pull in all the data from all the various reporting suites that Derrick. Then all of these things bubble back up into the final sessions table, because what we also want users to be able to do in sessions is actually run a series of queries like how many, for a given session, how many looks were there, how many books were there, and so on. Then we aggregate sessions up to some daily counts and weekly counts tables to make it easier for users to run queries on this, so that they don't always have to keep doing the aggregation themselves. And all of this is refreshed on a daily basis. They're all incremental models due to the data volume. There are parts of this that we're looking, or maybe some subsidiary views or other things that we're looking maybe to even move to an hourly approach to, but we haven't gotten there yet. So let's talk about flight searches a little bit. What is the table? It starts from January 1st, 2019 for all reporting suites. We have older data previous to that in Adobe Analytics, but as Many of you have worked with web analytics data know sometimes it's not all the necessary fields were consistently being tagged or populated in older points in time. So we looked at all the various sources and we said, yeah, it's good enough across all of them to be able to unify this from January 1st, 2019. As I talked about, it's one row per search segment, not per search. We also have some details around trip types. Is it one way, round trip, open jaw / multi-leg, that kind of a thing. And some questions that users or analysts would use when they're looking at this table are, for example, what are the number of searches on a given flight source and or origin and destination over the last 60 days? And what are the searches on a day-over-day basis via mobile versus web desktop? So contrasting channels. And it is interesting because over the last year or year and a half, we've seen a lot of volatility in user behavior that is not just about rapid changes in number of searches or number of bookings, but we've also seen changes in the distribution across which channels have more searches than others. And then some gotchas to keep in mind, always the intuitive gap between what a user would come thinking to a table versus what's actually in there. So we also have cases where there are bots doing searches on the JetBlue website. We have cases where there are people searching for routes that turns out JetBlue is not currently flying, or the routes are recently deprecated, or they're going to show up at some point in the future, but not at the date the person searched, all that kind of a thing. So those are all failed searches, but they're still logged. So if you're looking at this table and you're thinking, oh, I only want to actually analyze things that what we call officially countable, you have to explicitly go and exclude these other things. But the reason we leave them in there is there are some other use cases where you might want to actually say, hey, like what proportion of our searches are by bots? And then sessions, so one row per session. We rely on Adobe Analytics to do the actual sessionization, but when we're breaking this down into one row per session, we're using a visit start time, an Adobe Analytics visitor ID, a visit number, and then a source ingest. For the purposes of this presentation, we're calling a reporting suite. Sessions go back to the beginning of JetBlue Adobe Analytics recording, which is in 2013. And we also use this table to do funnel analysis or flow analysis through the website. There's a notion of grouping the various pages together to parts of the business process. Hey, here's the flight search aspect of things. Here's the booking aspect of things. How many people who did a search moved on to a booking, that kind of a thing. So some example questions: percent of sessions with a look in May 2021, or how many sessions advanced through the flight search step. Some gotchas: a session and all its associated entities can be classified as a bot. So if you explicitly don't want to analyze via bots, you have to pull those out. And also, particularly with some of the older data, the tagging and instrumenting and what value got put in what evar upstream. And sometimes we have to do trace back, particularly in the older data when we see some odd results. They change over the years. We always tell folks, look, back to the beginning of 2019, you're probably good. We have the data before that, but you should do some of your own validation to make sure that what the answer you think you're getting is actually what you're getting, right? Variable management. I think one of the reasons I really love DBT and the Fishtown folks in general is the thought leadership. One of the phrases that I think about every day or two is that analytics is a subfield of software engineering. And a really important rule in software engineering is don't just start embedding like random numbers like 42 or strings like when user ID equals Josh, right? Don't just put that stuff in your code. At least create a variable, put it at the top of your code, whatever language you're programming in, give it an informative name, give it some helpful commentary, also to explain the reason why or how, or hey, if you want to change this business behavior in the code, like this is the place you edit it, right? Because the maintainability aspects. So variables in DBT are a very helpful way to deal with this. There are a few different ways to use this. I'm using the word variable in this context in a slightly kind of approach here. I don't mean just literally the var statement. There's also a ginger way to do it, which local to a given model involves just using curly braces. And I try and show both of those approaches at the time. So both of them can be used in various circumstances. And an example of not a great way below of embedding a magic number, you go and read this code. What's a negative 728? I don't know. If you actually spelled it out and you had a couple of ginger variables here that said days and weeks and years, someone could look at this and go, oh, negative, all right, times the days. And oh, they're probably going 2 years back. Okay. I get it. Next slide, please, Derrick. A couple of ways to manage these. You can do it decentralized in individual models. So you just do the set command at the top, and then hopefully you're using an informative variable. This works better if you're just in one model. It's a little easier if you have a large project in the sense that your developer doesn't have to think, oh, I should go look at DBT project YAML. There's no bloat there. One gotcha with this does not validate on compile. So if you accidentally put a variable reference in your code this way, but you're not setting it at the top, Jinja just compiles it to empty space and you don't get a warning. That can catch you with typos, for example, and has caught me. Centralized approach is using DBT project YAML. This is better if it's present in multiple models. So for example, we have a couple of variables that tune like how we categorize or classify people as bots or not. We don't want to have multiple separate models that each have a copy of this variable. We want to put it in one place in DBT project YAML. It does validate on compile, so DBT will yell at you if you specify a variable that does not exist in your DBT project YAML. It does require some larger project-wide coordination and knowledge about the DBT project YAML file. Then finally, there are command line options that can work, particularly in coordination with the centralized model as well. For various reasons, we're not using those as much, but they're out there. So if you are interested in that, you could also take a look at the DBT docs. And then we've had a long running thread of, okay, say we start putting a whole ton of variables in DBT project YAML, that causes other problems. And so we have an open issue on GitHub about some options around that. So untangling cyclical dags, many of you have probably at some point or another have run into a scenario where you have business requirements where you need to calculate A and then B needs A calculated to do something where each of these are models, but then A also needs something from B, right? So in our case, we wanted to include in our final sessions table a count of the flight searches that were related to the session. But we also in the flight search table wanted the session key to say this flight search came from this session. So we have a cycle there. So what we did is we split the calculations into different models linearly. So A staging, in our case, is session staging, and then B, and then to A or A prime or whatever you want to call it. It does assume that your calculations are splittable. As I described above, in our case, we could build the sessions table with the sessions key, or the session staging, I'm sorry, with the sessions key. Then we could build flight searches and join and key back to that. And then we could build final sessions aggregating off of flight searches. I'm sure mathematically there are some cases where you're not flying splittable calculations. So we would have to find another solution to that. I'm not sure what it would be. Yeah, and I think I've talked through how we solve this issue already. But I think honestly, most projects of size that we work on, we come into this problem. So it's a pretty handy thing to think about. Just a few other random SQL or DBT thoughts. I think if any of us were to write an article for a newspaper or even more, with more effort, a book or something, we would intuitively understand that it's worth our time to put more effort to make it easier for the reader rather than saying, hey, reader, you need to expend more effort so I, writer, can expend less effort. But in programming, we're still working towards that. And I don't know if that flow of thought's always intuitive. So try and think about a reader, even if you're the reader, like can't count how many times I've gone to code 6 months from now and said to myself, who wrote this? It's terrible. Oh, I wrote it. Distinct, usually a Band-Aid. Try to avoid it. It usually means somebody who was writing the SQL said, there are some duplicates in here. There probably shouldn't be. I just don't have time to deal with this. So I'm going to, just use distinct. That causes other issues. Maybe the reasons the duplicates were in there were problematic and should have been addressed. Try and at least use group by. Even better, try and figure out what's really causing the dupes. Avoid, I've also seen IFF and then some sort of expression that evaluates to a Boolean. And then if it's true, then true. If it's not true, then false. But the expression itself already evaluates to true or false. That's a useless use of IFF, which if we have any kind of old Unix bash aficionados, that's a reference to useless use of cat. You can literally just use 1 = 2 instead. Same output, less work, easier to read. If you've ever found yourself in a case where you want to essentially aggregate or do an or an and as an aggregate function over Boolean output, the old school way to do that was to use max or min and then cast the true to 1 or the false to 0 and then do it that way. But Snowflake has native functions for these, and actually BigQuery does too, bool or ag and bool and ag. It's easier to read, it's clearer, it's more performant for the database. And aside from aggregate functions, there are also window and analytic functions for these as well. And then zero, just some nice syntactical sugar. There is actually a native Snowflake function 0 if you have a null and you just want to make sure it's 0 on the output rather than having to do a coalesce. Very minor thing, but just a little more upfront to your reader. Hey, this is what I want. So few things, I mean, like any software, DBT analytics project, big backlog, lots of things we still would like to do. Always clean up on descriptions and data knowledge. As I mentioned before, we'd like to do hourly ingest and reprocessing for some feeds and models. A lot more testing. Yes, we have 10,000 tests, but on 2,500 models, some of which have hundreds of columns, that's actually not a whole lot. Kindness to your future self, right? Performance improvements. And I've seen a lot of people talking in DBT Slack about kind of hash keys and performance on larger tables. We've been wanting to test out and validate, kind of measure specifically concretely how much using MD5 binary instead of MD5 would improve our performance on those, and then also thinning out some unnecessary columns. And then finally, we're just starting the journey into visualizations, which always tends to have feedback to your analytics project. And that's it. We're very grateful. I'm very grateful, and we're very grateful for the opportunity to present you all and for the opportunity to just share what we've learned. I don't know, Derrick, if anything you want to add?
Yeah, thanks, Josh. I think there's a Diana Ross quote. I'm going to paraphrase. We all need mentors, but ultimately we have to believe in ourselves. So hopefully this talk can give you a few tips and tricks to help you feel confident working with larger tables and web analytics data. And happy to take any questions.
Thank you so much, Derrick and Josh. So many of the challenges that you were overcoming all triggered memories for me of solving very similar things. I think I remember when I first was reading about DBT back in, I don't know, it was probably like 2017. And no, I wasn't able to convince my team at the time to use it, but we were doing that pattern of defining things in case statements in the code and making sure that ID5 actually equals whatever human readable status. That's probably one of the most proliferated code patterns or anti-patterns, I might say now, that I've seen. So that was such a great presentation. Questions have been quiet, but I've always got plenty, so there's no worry there. I would love if Jeff, actually, who's in the audience here, member of the community, he chimed in with an answer, but I would love to hear your articulation of, you mentioned generating a hash key as a unique ID in your table based on values where you're combining values that are in other columns. And I've seen teams do this with an auto incrementing key instead of doing that hash. And I just was curious if you could speak to the solution you chose, like the benefits of doing that.
Derrick, would you like to take that, or do you want?
No, go ahead.
So it's a great question. It's a pretty deep topic. I feel like we could do a whole presentation on key management. Auto incrementing keys will get you into a world of pain because they're not idempotent. And I've literally had this bite us, not on the JetBlue project, but on other projects where we started out using those, particularly with incremental models. If you generate, say you have two models, you have model A and model B, and say you're doing a little bit of Kimball modeling, model A is a dimension and B is a fact table. So the fact table has a key reference back to the dimension. And say they're incremental models, which is where this really starts to become a problem. Say for some reason you drop model A, like you've done incremental runs on both of these, you've created model B, there are a bunch of key references out of model B, and you're using auto incrementing keys and you're not using hash keys. Then for some reason you need to drop table A and recreate it, or you get new rows added to it or whatever, you can end up in a situation because the auto incrementing keys the same row and table A can actually get a different key value in the future. You will get broken keys. The row in the fact table will point to either an old stale row in the dimension table that no longer exists, or even worse, because auto incremented keys often tend to start from 1, you might have the same key present in the table, but it might be assigned to a different row. So your dimension row or your fact table row would actually point to the wrong row in the dimension. So what we do is we generate hash keys and we use combinations of underlying business attributes that should be unique in the table, so that if you were to regenerate the table over and over, you would always get the same hash key based on the same attributes in the row.
Thank you. Thank you for explaining that. That was such a clear articulation. Okay. The other thing in the presentation, one piece of detail that I missed, I was hoping you could go into a bit more detail on the internal tooling that you built to solve that. Like, I think it was the recasting of column names and maintaining that consistency. If you could just recover a little bit of that.
Sure. Yeah, absolutely.
You
So
get a better, clear sense on, yeah, how you accomplished it and who, I imagine you worked with stakeholders in the business a bit to do some
yeah,
of that.
exactly. So we had rights, a lot of stakeholders that are consuming this data. So just from a data governance perspective, we pretty much relied on we have an internal web analytics team. So we deferred to them really on the renaming conventions. And so there's just some back and forth between the team. There's some intuitive names that we thought we would use as a first draft and then got feedback from that team. But it did end up being a lot of back and forth. So we'd have someone go in and change what EVAR was being renamed to. And then you want to do it sounds simple to just use the find and replace. And I think in a lot of cases it does. But just from multiple changes, we'd end up with these errors where we'd try to run our models and it'd fail because of a name not being properly handled in a downstream CTE. And so this is where I was just like, okay, we could sit here. Also, we have a very large DBT project. So this has gotten better since we initially started this, but there was like a probably good 6 minutes that we'd have to wait for our project to compile just to build a single model. So that you do that 2 or 3 times and you're just like, okay, let's just automate this. And so that's when we just turned to writing a Python script that would take that document that we were sharing with our stakeholders with just mapping the raw columns, flight search to this is a string and here's some comments that we have. So we maintain that in our model. And then it just built out the scaffolding for us. So we just did that to initially get the models built and running. And then as we've maintained them, I think if you're making 1 or 2 changes, it's a lot easier just to go in and make those, push those commits and then track them that way instead of have to worry about huge knot you've created, especially with so many columns. And actually, my vision is to maybe submit this as an enhancement for CodeGen to be able to take in some input and build out more complex scaffolding. And also happy to share that code too if anyone else would find it helpful.
Yeah, I was curious. So does that end up being a file within your repo? Is it a CSV upload?
Yeah, it's just a CSV. So
Okay.
you've got raw column,
Yeah.
you've got rename value, rename comments, retyped value, retyped comments. So it just goes for in operations and then adds in the CTEs and associated comments.
Okay, very cool. That helps clarify. Yeah, I wasn't sure if there was a separate app. It sounds like just to generate to do the initial.
Exactly.
Yeah, cool. Thank you for clarifying that.
Mm-hmm.
Derrick not Derrick, question for Derrick. And this is from, I apologize. Oh, this is Will Hatfield. Will, do you want to come off mute and ask a question?
Sure. Hey, Derrick, just that pattern with defining a list of columns as a Jinja variable versus just using the dbt star utility and the accept pattern. I wasn't quite not sure if I follow when you would use one versus the other.
Sure. So with the setting of the common columns, this is when I think it's helpful, particularly with Adobe Analytics or Event Analytics, because you've got a lot of different tables and stage tables that you're going to be joining in your star models. And so this is where perhaps in your star model, you're going to be selecting the same columns from all of those tables, in addition to the some unique columns from those downstream stage tables. So that's where defining those common columns comes in handy. So that's like with our flight searches. We might be looking at flight searches that occur on a mobile app or on a desktop site, and we want to pull in some just default data like a timestamp that's going to be shared amongst all of those device tables. And then perhaps that EVAR is a little bit different between mobile app versus a desktop site. So that's then where we're going to have those unique column names that we include. And so that is going to just keep using that shared column variable, just going to keep the select statements a little bit simpler. And then when it comes to the star macro, that's when again, if you want to select, I guess we could do this. I'm just thinking here.
I think if I could jump in for a sec, Derrick. I think the common columns, Will, are really important. We're doing some really big unions. And so the explicit ordering of the columns to make sure that it's exactly in the particular order between the unions is a really big deal. If we used the star macro, in that scenario, we'd be vulnerable if there's ever a future change in the underlying table, that the ordering of the columns coming back from the underlying query would not be guaranteed. So if we really have to make sure the order of the columns are exactly the same and match up between the unions, that's where we need the common column approach. Good question, though.
Yeah, that was a great question. Is that when you define the group of columns, I'm just going to expose my own, I don't know this exactly. Is that a macro that you built?
No, it's literally just, here's a big chunk of text with a set statement at the top of the DBT model. Just like a lot of coding things, this wasn't necessarily fully planned from the start. It was more like us doing code review on some of these models and saying, wait, we have 80 lines of code repeated in 4 places, but I, as the reviewer of the code, had to go through and say, wait, is this really exactly the same? Or is there like one column extra somewhere, or what's going on? And then when we realized they were exactly the same, we said we could cut 200 or 300 lines of code out and make it a lot easier for the reader and all that stuff. So that's how we refactored it out that way.
Yeah, sounds like maybe macro potential. There's a way to.
No argument.
Yeah, okay, cool.
Yeah, probably could, yes, we could probably do better.
That's how, I mean, it's one of those things where you keep making incremental improvements until you realize there's an even better way to do this. That's awesome. Any other questions from the group here? I haven't seen anything else come in. For a second.
I'm just curious, Jillian, do you know, my Slack ignorance here, I was trying to figure out how to do a poll on our how-to channel. Do you know how to do that, or am I putting you on the spot?
Yeah, you want to ask a question?
I was just curious. I thought, how many folks are already working with web analytics data, whether Snowplow or Adobe Analytics or something else? How many are not, but think they will be in the near future, and how many that's not on the radar right now? I guess were my 3 options. I think Jillian has it.
Hold on. Yeah.
And,
fingers.
And bringing up Snowplow is a good point. There's the nice open source Snowplow package. So it's helpful to see how that's structured and what some of those models look like. Nothing exists right for Adobe Analytics today. I think that it'd be helpful, can certainly have those conversations with our raw staging models, but I think it's such a customizable reporting suite, but perhaps there's an opportunity there.